Okay, today we're going to work on solving proportions. I'm going to do a few problems for you. Let's go ahead and jump in. So what you notice here on number one is like any other solving of equations, we have an unknown variable. The goal here is to find the value of n. So there's a number of ways to approach these types of problems. The way I recommend, I call butterfly math, and essentially you take the opposite corners, in this case 8 and n, and you multiply them. So what is 8 times n? That would be 8n. Then you put your equal sign, and then you do the opposite corners. 10 times 10. What is 10 times 10? That is 100. And now this looks like a more familiar equation that we can go about solving. We can divide both sides by 8. Right now the n is being multiplied by 8, so we'll divide by 8 to undo it, allowing the 8's to cross out on one side, leaving us with just the n on the left side. And now we have to simplify our fraction. I noticed that 100 can be divided by 4, and 8 can also be divided by 4. So we'll divide both the top and the bottom by 4 to simplify the fraction. So that would be 25 over 2. N equals 25 over 2. Okay, let's look at number 2. Similar, we can multiply our opposite corners. The reason I call it butterfly math is because it kind of looks like a butterfly when you make it. So what is our 5 times x? That would be 5x. Then we put our equal sign, and now we're multiplying our 7 times 3, which equals 21. Now it looks more familiar. Right now the x is being multiplied by 5, so to undo that, we can divide by 5. But of course, we have to do it to both sides. This allows us to cross out the 5's on one side, leaving us with x equals 21 over 5. Okay, so let's get down to a little bit more complicated one here where you have not just one thing on the denominator, but two things. The way I recommend starting these is by putting parentheses when there's more than one term on any part of a fraction. So same rules apply. We're going to multiply 7 times 5, that equals 35. But then when we multiply the other side here, we have 10 times b plus 5, and we keep it in parentheses. Now this is going to force us to take another step here, right? We will have to distribute our 10. So 10 times b is 10b. 10 times 5 is a positive 50. Now, we know we're going to try to isolate the b. That's the game here. But first, we have to get rid of this 50. So we can subtract 50 from both sides. That'll allow those to cross out. And 35 minus 50 is a negative 15. And that will equal our 10b. Last and final step, we can divide both sides by 10. This allows us to cross out the 10s on one side, and we're left with negative 15 over 10 equals b. Looks to me like both those, the negative 15 and the 10, can be divided by 5. So we're going to simplify our fraction down, and I'm going to go ahead and take the b and put it here. B equals negative 3 halves. Let's see if they get any more complicated. So here we have some that have both numerators and denominators with multiple terms. So similarly, start by putting your parentheses around these. We have to keep them together as a bunch. So same rules apply and multiply the opposite corners. When we multiply 2 by n minus 6, we get 2 times n minus 6. Then we put our equal sign and multiply the opposite side, which is 9 times n minus 7. So now this is going to force us to distribute twice. 2 times n is 2n. 2 times negative 6 is negative 12. 9 times n is 9n. And 9 times, where's my stylus here? 9 times negative 7 is negative 63. So whenever we have variables on two sides of the equation, right? We have two sides of the equation. We have this n on both sides. We have to commit to one side. We can either move the n's to the left or move the n's to the right. As a general rule, I just like to make it such that we end up with a positive number because I feel like those are friendlier. So what I'm going to do is subtract 2n from both sides. That allows us to eliminate the 2n from this side. So we're left with negative 12 equals a 9n minus a 2n is a 7n minus 63. Now the goal is to isolate this n so we can add 63 to both sides. That'll allow us to cross off the 63 here. And we're starting at negative 12. Adding 63, we're going to end up with a positive number, and that will be positive 51 equals 7n. And now we can, let me rewrite our equation where we're at here. So now we can divide both sides by 7, and we can get n equals 51 over 7.